Hello, my name is Mary Jo Finder and this is Math for Middle School. Today we're going to go over how to compute constant proportionality between quantities using the values in graphs. What you'll need today is paper and pencil. Okay, take a quick second, let's get ready to learn. Last week we talked about how tables are proportional. And when we talk about proportionality, we want to look at the two quantities and they need to share a common ratio. Now, that common ratio is called a constant of proportionality. And you can find that the constant of proportionality by using the equation k equals y divided by x. In the table, as you can see, this is a proportional table and it shares some common characteristics. The first is the change in x is going to be constant. Now, the left-hand side of your table is going to be your x value. And if you notice, each of the lines or each of the quantities in the x tables differs by 3. So we would say that this has a constant change of 3. The second characteristic is the constant change in y. And in this table, as you can see, the constant change in y is 5. Now, when we look at that constant proportionality needs to carry out throughout the table. It doesn't have to be the same left to right side or x to y, but all of the x need to have that constant change, all of those y's. If we also look, we can say, okay, I can divide each of those y divided by x down to a common ratio, which is 5 to 3 or 5/3. Now, let's take a look at this, how it looks in a graph. So when we talk about proportional relationships in graphs, we're really looking for two things. The first is that it starts at the origin. Origin has an ordered pair, and that ordered pair is 0, 0. As you see, the table on the left does start at the point 0, 0. The graph on the right does not. Here's 0, 0 on the one on the right. You'll notice it starts at the ordered pair 0, 10. Automatically, if a graph does not start at the origin, it's going to be non-proportional. The second thing we're looking for is a straight line. Does it have its straight line going through the rest of the graph? The one on the right does, the one on the left does as well, but because the one on the left is the only one that starts at the origin, we're going to say this graph is proportional. For a graph to be proportional, it must have both characteristics. It can't just have one or the other. So let's look at some examples. Our first example is we have a situation, Victor is making a backsplash in his kitchen. And the table suggests that we have rows 0, 1, 2, 3, and 4. The y value, or the number of tiles, represents how many tiles are total in those rows. So if we notice 0, 0, we can make an ordered pair by taking the left column and the right column, putting together. This represents the x, this represents the y. And when you put your ordered pair together, make sure you put your x on the left, your y on the right. So if we look at our graph, we're going to start at 0 and we're going to go up 0. So yes, in fact, it does start at our origin. That's our first requirement. The next one is we're going to go ahead and plot our points. So we're going to go 1, 7, and we're going to put that dot there. Then we're going to go 2, 14. Make sure when you're plotting these points, you always do the x value first. 3, and then we're going to go up. 21 is going to go right there. And then the last one, 4, 28. It's going to go right there. Now we're going to draw a line starting at 0, and my line is straight. So because I have our two characteristics beginning at the origin and our line is straight, we're going to say that this graph and this relationship for Victor and the backsplash is in a proportional relationship. Let's take a look at another one. So this time we have the perimeter of our square based on the length of the sides. Now we're going to go ahead I'm going to go ahead and plot the points for you as I read you the table. Remember, our left side is our X, our right side is our Y. When we do our ordered pairs, we're going to put X, comma, Y. Make sure they're in that order. If they're not, it's not going to work out too well for you. So we're going to start at 0. We're going to go up 0 for our first ordered pair. Okay, it's looking pretty good for us because we do have our origin now. And then we're going to go over 1 and up 4. Now you'll notice that my over 1 is actually over 2 because this middle line represents 1/2. So make sure you're looking at those scales on your axes because sometimes they'll do what I call skip counting and you might accidentally put it on the wrong spot. Okay, so our third ordered pair is going to be 2, 8. Then we have 3, 12. And then we have 4, 16. As you can tell already that our line is going to be in a straight line because I've already drawn an imaginary line and I can see that straightness coming through. Always go ahead and draw your line and make sure it's straight. Our two characteristics starting at 0, 0 in a straight line, we're good to go, so this graph is proportional. So let's take a look at Angie. Angie's going to get paid for babysitting. Now you'll notice the first thing, here's our X, here's our Y, that's always the first thing I look for. Our first ordered pair is going to be 0, 14. So when I go over 0, I'm going to start at 0 and go up 14, notice how it's not going to start at the origin. So right now, without even drawing any more lines, I know that this graph is non-proportional. Now, one thing that you need to remember when a graph is non-proportional, that point 0, 14 means that Angie's going to get $14 for just showing up. She's not going to work any time at all and earn $14. Let's go ahead and graph so we can see if this forms a straight line or not. It may not have either of our characteristics. So we're going to go over 2 this time. Remember, it's skip counting. That's 1/2. So we're going to go over 1, up 21. We're going to go over 2, up 28. Over 3, up 35. Over 4, up 42. Now you'll notice you can draw a straight line using this. So it does have our straight line characteristic, but you'll notice it doesn't start at the origin. So because of that, we automatically have to kick it out at non-proportional. Now let's take a look at some graphs. Remember, our two characteristics for proportional graphs is one, that it begins at the origin. The second, it has a straight line through the graph, including the origin. So if you notice, this particular graph does start at our origin. Right there it is. It does have a straight line going through the origin, so we're going to say this graph does meet our characteristics for proportionality. So we're going to call it a proportional graph. Let's take a look at another one. Remember, our two characteristics goes through the origin in a straight line. Well, right here is our origin. Notice that our graph is all the way down. It doesn't go through our origin. It actually crosses At 0, -3. So our origin ordered pair 0, 0 isn't in play here. So automatically, even though it does contain a straight line, we have to say it's non-proportional. Let's take a look at another graph. This graph I kind of like. It's kind of one of those whimsical graphs. And notice, remember our two characteristics? Goes through the origin, straight line. Here is our origin. The line goes through the origin, but really is it a straight line? No, it's not. It's really one of those wacky, curvy lines. So because it only has one of the characteristics, this particular graph is non-proportional. That concludes our lesson for today. Let's take a quick review. Remember, I have two graphs here. The characteristics of proportionality between quantities on a graph is it must begin at the origin. And remember, the origin has an ordered pair of 0, 0. We look for those in tables as well. And we also have a straight line throughout the entire graph. You'll notice our first graph does start at 0, 0, and it tells us that we don't have any cost for the number of hours, whatever our labor happens to be. And if you come over in savings account, notice our first ordered pair is right here, and that coordinate is 0, 20. So our account is actually starting with $20. So it doesn't start at our origin, so it's not proportional. Even though it does show a constant rate of increase throughout our savings account, it's non-proportional. So this is our only graph, the one on the right, that would be considered proportional. It has our ordered pair, 0, 0, and it has a straight line. Remember to work on your proportionalities during the week so you can continue to improve. It's been my pleasure working with you today in class. My name is Mary Jo Fender, and I'll see you next week.